I know exactly what you're thinking. You've got this Hangman assessment, you've fired up VS Code, and your fingers are just itching to type, "Print, welcome to Hangman." Well, stop, right there, because that isn't engineering, that's just guessing. To really nail the top marks in this task, you need a professional roadmap. So, in this explainer, we're going to map the 8 phases of the software development lifecycle directly to your assessment notification. We're going to turn this simple coding task into a real engineering project. Let's dive in.
All right, so here's our game plan. First, we're going to shift our mindset from just coding to actual engineering. Then, we'll lay the foundation by figuring out what we're building, we'll create a super detailed blueprint, then we'll do the build, and finally, we'll handle all the testing and delivery. Trust me, following this roadmap is your clearest path to getting this done right.
You know, the single biggest mistake you can possibly make is jumping right into the code. Yeah, I know it feels productive, right? But it's a total trap. It just leads to messy code, you end up missing key requirements, and, well, you lose marks. The professional way, the way that works, is to follow a structured process.
And this quote just hits the nail on the head. Just opening up an editor and hoping for the best is never going to work. Real software development is a disciplined craft, not just some random walk through a bunch of code.
So what is engineering then? What are we talking about here? It's really simple. It's about swapping out all that guesswork for a structured, proven process. It's about having a plan. And that plan is the software development lifecycle, the SDLC. And look, this isn't just some theory from a textbook. It's the actual industry standard for building quality software. And it's exactly what the syllabus expects you to do.
So let's start building this thing properly. Before you even think about designing or writing a line of code, you have to create a rock-solid foundation. And that all happens in the first 2 phases of the SDLC, where we define exactly what we're building and the rules we gotta follow to build it.
Phase 1 is all about user requirements. Simple question, what does the software have to do? Your assessment notification actually makes this super easy. It literally lists minimum game features, things like difficulty levels, a scoring system, guess options. So your job is to open up your logbook, write a heading, user requirements, and just list them out. Doing this proves you actually understand the scope of the project.
Next up, Phase 2, the technical specifications. Think of these as the non-negotiable rules. Again, your assessment spells them out. It's got to be a terminal-based app written in Python using VS Code and GitHub. But here's the bit that so many people miss. You also have to document the data constraints. So get back in that logbook under a new heading, Technical Specifications, and write down that the score has to be an integer and the word list is going to be an array or a list. And now we get to what is, without a doubt, the most critical documentation stage of them all, design. Think about it. You would never ever build a house without a blueprint. So why would you try to write a program without a proper design? This phase is where you plan out everything before you write a single line of code.
And hey, if you need a little extra motivation to take this seriously, just look at this. Part 1, your documentation, is worth a massive 35 marks. The quality of your blueprint directly, and I mean directly, impacts your grade. So let's make sure it's perfect. First up in our design docs is the storyboard. Now, this isn't about code logic at all. This is all about the user's journey. You're just visually mapping out the different screens. How does a user go from the main menu to picking a difficulty to actually playing the game, and then finally seeing that win or lose screen? Draw it out. Next is the Level 1 Data Flow Diagram, or DFD. Now notice this maps the movement of data, not the program's logic. And you absolutely have to use the correct symbols. The player, that's the external entity, goes in a rectangle. Their guess is the data flow, which is an arrow. The check guess action is a process, so it goes in a circle. And this is a big one. Your word list is a data store, which is always shown in this 3-sided rectangle.
Then there's the data dictionary. This is basically the single source of truth for all your variables. For every important variable, like score or guessed_letters, you have to define its data type, write a clear description of what it does, and list any validation rules. For example, score is an integer, and it must be greater than 0. See, this is the kind of detail that separates a guess from a properly engineered plan.
And the last piece of our design puzzle is the flowchart. This is where you finally get to map out the program's actual logic. Using these standard symbols, you're going to outline the main game loop, that's your big while loop, and the decision-making parts, which are your if-else statements. And remember this key rule. A diamond shape is always for a decision, and it's the only place your logic can branch off in different directions. And let me be absolutely 100% clear about this. You must complete your storyboard, your GFD, your data dictionary,
and your flowchart before you even think about moving on to development. The SDLC is a sequence. You have to finish the blueprint first. Period.
Okay, blueprint is done. Phew! Now and only now do we actually get to write some code. Welcome to the build. This is part 2 of your assessment, and it's broken down into 2 very distinct phases, development and integration.
And this is the big one. This part is worth a whopping 40 marks. All that hard work and planning we just did in the design phase, it's all about to pay off right here. It's what's going to help you build a high-quality working program that earns every single one of those marks. So what's the difference between these 2 phases? Well, think of it like this. Phase 4, development, is about writing the core logic by itself. You're building the engine of the car. You're just laser-focused on getting that main while loop running and making sure the if-else logic for checking guesses works based on your flowchart. Then, Phase 5, integration, is about connecting all the other parts. This is where you hook up your different functions, and if you decided to add extra features like a timer or a high score list from a CSV file, this is where you import libraries like time or CSV and make them talk to your main code.
All right, the code is built and all the pieces are connected. We are on the home stretch now. These last few phases, testing, delivery, and maintenance, are all about quality control, proving your code works, and then reflecting on the whole process. Okay, I need you to really listen up here. Phase 6, testing and debugging, is not just about fixing your project. It is, and I mean this, your single best study guide for that final in-class exam. The work you put in right here is going to give you the exact examples and knowledge you need to absolutely ace Part 3. You have to systematically test your program, and you have to record everything in your logbook. That means creating a test data log, just like this one. Test the boundaries. What happens the moment the score hits 0? Test with bad data. What happens if the user types in a 5 instead of a letter? And please, use the VS Code debugger. Learn to set breakpoints and step through your code line by line. That's how you'll find those sneaky logic errors you'll need to talk about in your exam.
Phase 7, installation, is pretty straightforward. Your final code has to run from the terminal, and you submit it on both GitHub and Canvas. Easy enough. Phase 8 is maintenance. Now, in the real world, this is about fixing bugs and adding new features later on. For this assessment, maintenance means 2 things: your reflection report and your in-code comments. Use comments to explain your logic clearly, and in your report, you can explain how you might have used AI to help refactor or improve your code. And there you have it. We have walked the entire roadmap, all the way from a simple task to a fully engineered, tested, and documented solution. Now it's time to put it all together and go claim your engineering victory.
So here it is, your final and most important action item. Open your logbook. Right now, create a brand new page and call it Cycle Plan. Now, write down these 8 phases just like a checklist. This is your personal guide. As you complete each phase of the project, physically tick it off. This simple little act is going to keep you on track and guarantee you follow the proper engineering process from start to finish. And that right there is how you turn a simple coding task into a massive engineering victory. You've got the map, you've got the plan, now let's get to work.